Well, hi everybody. Now, this is the third in our series of transformations of functions videos. This is the one on translations, following the first one on dilations and the second one on reflections. So I hope you're starting to get used to this stuff by now, and the way that I apply the techniques for coming up with the both the transform functions given the steps, or the forward technique, and secondly given the steps given that you have the beginning and the transformed functions. So let's go for it. I'm sure you'll find this a lot easier if you looked at the previous two videos already. It'll just be the same old, same old. So let's go for it. What is a translation? A translation is the movement of a point xy by a specified number of units, either up, down, to the left or to the right. That's what a translation is. Let's do some calculations using my recommended logical method. There are two types of calculations, yes, that you will encounter. The forwards, where you are given the original function and the transformation steps required, and you're required to come up with a transformed final function. E.g., f of x equals root x, determine an equation for the image of f of x after a translation of 4 units to the left, and secondly a translation of 3 units in the positive y direction or up. So let's do A today. Hooray. We've got that graph to make everything clear to us. Now we've got to go 4 units to the left, so that's going to be quite clear. Let's do it. There it goes, and there's our finished result. So it's x minus 4 and y. So now we'll put that into an equation or a calculation situation. So we've got x and y goes to x minus 4 and y, and then that is our final transformed point, which I call x dashed and y dashed. So now let's go for it. Here comes the original equation that y equals, I call it y equals f of x equals root x, and with the forwards technique we're going to get the key to everything, which is that, and we're going to make x and y the subject. With the backwards technique we make x dashed and y dashed the subject, but for this technique we're using x and y the subject, and let's just do that. So we can say that x equals x dashed minus plus 4, sorry, and we can say we know that x is x dash minus plus 4, sorry, and y is y dash. So we've made x and y the subject, so we're going to substitute for x and y into this star equation, and what do we get? Okay, so y dashed, which is the same as y, equals f of x dashed plus 4, and that's the same as the x dashed plus 4 is the same as x, equals root of x dashed plus 4, because x dashed plus 4 is the same as x. So that looks like we've got it, haven't we? We can drop the dashes now, because we've got our final transformed result. We can say the image is f of x plus 4 equals root of x plus 4, or if you like, you can say y equals the root of x plus 4, just depending on the way they worded the original question, but that's pretty flexible, whether you put y or whether you put f of x plus 4 or whatever, in that particular final step. Happy? Alright, so we've got to do B now. Oh yes, the graph, sorry, the graph. Look at the graph. That was the original there, that was the graph. And that's the final. Look at that. It went backwards by 4 units. Isn't that interesting? Yeah, it's pretty marvellous. So here comes the B for you and me. Translation of 3 units in the positive y direction. Let's draw a graph and do it. Here it comes. Reaching for the stars. There we are. That is the final result. So we do the same procedure that I've been showing you. X and y goes to x and y plus 3. And that's x dash y dashed, the transformed point. Now, the original equation is y equals f of x equals root x, that's equation star, and let's do the key to everything now. X dashed equals x, it does, doesn't it? Yeah, x dashed equals x, and y dashed equals y plus 3, mate. Now, in the forwards technique, we make x and y the subject. So x is x dashed, y is y dashed minus 3. Substitute the key to everything into equation star as x and y in terms of x dashed and y dashed, and you get that. Have a good look, see if you agree. I think I agree. So now you solve it for y dashed, and you get that. Now that is the end result, guys. So we drop the dashes now, and we say that is the image, as I've been doing already. Okay? Excellent. Now, C graph, here we go. There's the original, that's root x, and here is the final version, look at that, translated up by 3 units. Okay? Beautiful. Now, there are two kinds of calculations you will encounter which you'd be well aware of by now, and we're now going to do the one we've just been doing is the forwards, here comes the backwards. We are given the original and the transformed final function. We are required to come up with the transformation steps that have been applied to get to the final transformed function, and here's our example. Determine the translations which would transform y equals x squared into y equals x squared minus 5, or in B, y equals x plus 3 all squared. Okay, let's go with A. Now that's our original there. This is backwards now, remember. So we're putting the dashes there. We're saying y dashed equals x dash squared minus 5. Now, this little gremlin here, we've got to fix him up. He doesn't belong to an x or a y. He doesn't belong to an x or a y, so we've got to make him belong to an x or a y. And we can't make him belong to this term because that's an x squared term. If he was going to belong to the x term, he'd have to be in the bracket with that x, right? That's no good. You can't say he belongs to the x squared term. He has to belong to either an x to the power 1 term, e.g. in the bracket, and squared with the x, or over here with the y. I think I've just enunciated that underneath the writing here. Yeah, the minus 5 is an extra term. To put the equation 2 into equivalent form, it needs to belong or be attached to either an x or a y term, not an x squared term. It has to belong to the x with an exponent of 1, or y with an exponent of 1. Since the x term is x squared, the minus 5 can't belong to it. Clear as mud? No, it should be fairly clear. Now, let's just fix that equation 2 up and make it in equivalent form. We'll just shunt that minus 5 over the other side and make it plus 5 with the y by adding 5 to both sides. We'll get y dash plus 5 equals x dashed all squared. Now they're in equivalent form. Okay, it belongs to the plus 5 belongs to the y dash. So they're in equivalent form. We're going to equate the equivalent terms from 1 here and 2a here, right? So what we can say is the y dashed plus 5 equals the y. Looking at them, does it make sense? Yes. And we can say that the x dashed equals the x. That's good. Now, because we're going backwards, we're going to solve for the y dash and the x dashed. Y dash is y minus 5, and x dashed equals x. So therefore, you can see, ladies and gentlemen, that we had to take the x. There was no transformations there because they're both the same, equivalent to each other, without any extra terms. This one here, we had to subtract to get to y dash. We had to take 5 off the y, so you had to go down 5 units to get to y dash, right? Minus 5, subtract 5, go down 5 in a y sense. This represents a translation of 5 units down or in the negative y direction. Yes, it's very easy, isn't it? Okay. Now we're going to do B. Y equals x plus 3 all squared as our transformed function from the original one of y equals x squared. That's it. I put the dashes there to make sure we're clear that this is the transformed function. Okay, that's pretty clear that 3, that extra term there, he belongs to the x. He belongs to the x. So we don't have to fiddle with that at all. They're actually in equivalent form. Now we equate equivalent terms, and we can say that y dashed equals y, and x dash plus 3 equals x. Solving for y dash and x dash now. Don't have to solve for y dash, but x dash we do. X dash equals x minus 3. Now, very clear, very, very clear. Thus, we would have to take x and subtract 3 to get x dash, so we'd be moving the original function 3 units to the left, or the negative x direction. Okay? How's it going? Yes? That's good. Now we're going to do the quick learned method, both forwards and backwards. This is my caveat. The technique is a learned cookbook technique based on the foregoing logical method, actually, but it's not my preferred technique because it's included for the sake of completeness. It's very fast, sleek. It's beautiful if you know how to use it, but you can founder on the rocks of the oceans of transformations if you don't know what you're doing with this. So it's got dangers. Forwards, let's go. You are given the original function and the transformations required. you have to come up with the final transformed function, e.g. f of x equals root x. Determine an equation for the image of f of x after a translation of 4 units to the left, or a translation of 3 units in the positive y direction, or 3 units up. Now, where are our rules, our learned rules? For a translation of n units to the left, or in the negative x direction, we replace x with x plus n. Again, the game of opposites. So if you go in the negative x direction, you replace x with x plus something. For a translation of n units to the right, or the positive x direction, the plus x direction, you replace x with x minus n. For a translation of n units down, y direction down, negative y direction, you replace y with y plus n. And for a translation of n units up, or the positive y direction, you replace y with y minus n. Yes, it's the game of opposites. So here comes A today, hooray, translation of 4 units to the left. So what we're going to do, guys, is we're going to take the original equation and we're going to replace x with x to the left, did I say? Yes, so with x plus 4. There it goes. That's it. And there's your image. Right? Here comes B, fills us with glee. What are we doing? Translation of 3 units in the positive y direction. That means we're going to replace y with y minus 3. There it goes. There it goes. And you solve for y. My oh my. And you get that. Now now you can write our final answer. You're either going to write y equals root x plus 3, or f of x plus 3 equals root x plus 3. Yeah? That's it. Okay, now that's the forwards. Now we've got to go backwards now with the quick cookbook learn technique. In backwards, you are given the starting function and the transformed function. You have to come up with the transformation steps that have been applied. Now, e.g., determine the translations which transform y equals x squared into, we did this before, that one or that one. Now, what are our rules? Here they are. Okay, so let's do A. Now, again, you've got to, there's the original, there's the transformed beastie. This 5, he's an orphan term. He's no good like that. He's got to be brought over here and belong to the y term, because he can't belong to the x term, because the x is an x squared term, right? He'd have to be in the bracket with the x if he belonged to the x term. Now, so the 5 is an extra term which must belong or attach to a single x or y term with an exponent of 1, as I was explaining. Therefore, we'll put it like that, right? Now you can see, guys, you can see to get the transform function, you've added 5 to y. That means that that's a, what is it? It's a translation 5 units down. Yes? Down, or in the negative y direction. You've got to think opposites with this stuff. Now, with B, right, we've got, that's the original on the transformed, the dashes have been on the transformed. So look, you've got x plus 3, you've changed x to x plus 3, therefore that's a translation of 3 units to the left. Yes, it is. That's how it goes. I think that's the end. Yes, it is, and you're a star. Hoorah, you'll go far, huzzah, and that was a short video, 13 minutes and a half. So, hope you got something out of it. And go back and have another look if you're not sure. And we'll see you in the next exciting installment, which I think is going to be combo translations, or combo transformations, I mean. A little bit of everything thrown in. Okay, thanks very much. Have a wonderful day, and we'll see you.